ABCD is such a quadrilateral that A, that is one of the vertex, is the center of the circle passing through B, C and D. Prove the following. First thing is, you guys have to draw the diagram. So pause and draw the diagram. So we have a quadrilateral which is going to look something like this. So what do we have? We have, say this to be point A, B, C and D. And I'm going to join this because we have to prove that CBD, this particular angle, plus CDB, this particular angle, is equal to half of BAD, this particular angle. Okay. So how is that they are related is something that you guys have to start thinking about. I'll give you guys clues as and when we go. So first thing is, I will talk about this angle as 2 theta. So to begin with, we have to write to prove. What is that we need to prove? So we have angle CBD plus angle CDB is equal to angle PAD by 2. Then we have to talk about proof, which begins with let angle BAD be equal to 2 theta. Okay. Now, how is BAD related to C? Yes, we have to make use of the property or the relationship between the arc's angle with the center and the circumference. So we will talk over here about angle PAD. Okay, let me redo this. I'll approach in a different way. I'll show it to you guys first. So we have this particular angle. Not very happy. Yeah, this particular arc actually. Let me call this as point P. Okay, this point I'm calling it as P. Now, whatever angle is over here, if to say this is 2x, this will be x. The arc, the major arc PPD is subtending an angle of 2x. So this arc will subtend an angle of x with the circumference, as it's subtending angle of 2x with the circle. Okay, so this is the whole funda. Understood? So first thing is, we have to find reflex angle of BAD. How will we do that? It's quite simple. BAD plus the reflex of BAD will be equal to what? 360 degree. Is it not? Right? So this is because of, yes, angles around a point. Next thing, the reflex angle of BAD is equal to 360 divided minus 360 degree minus 2 theta. Okay, this is 360 degree minus 2 theta. Next, what does this imply? This implies that the major arc of PBPD is subtending an angle of 360 degree minus 2 theta at the center. Right? Is it not? We need to explain this because we have to relate it to angle BCD. Therefore, the arc, understood? This is how you make use of the language, and this is how you connect things. Subtends angle of how much? 360 degree minus 2 theta divided by 2 with the circumference. Correct? Right? Makes sense? of the circle. The circle. So indirectly we stated the theorem. Understood? Therefore, angle BCD is equal to 180 degree minus theta. So what did we end up with? We ended up with this angle being equal to 180 degree minus theta. Okay. And now what do we have? We have in triangle BCD. What are we looking at? We are trying to relate, that was your clue, we are trying to relate 180 degree minus theta with angle CBD and CDB. We are trying to relate to with these two angles. So how is that we are going to do it? Yes, we are making use of angle sum property of triangles. Okay. So whenever you get angles in a triangle, it's angle sum property, is it not? Plus CDB is equal to 180 degree. But we have angle C to be equal to what? Oh yeah, this is because of angle sum property of triangle. This is 180 degree minus theta plus angle CBD plus angle CDB is equal to 180 degree. So 180 gets cancelled. We have angle CBD plus angle CDB is equal to theta. Okay, this is by substituting from 1. This is by substituting from 1. Now, but theta is what? Theta can be written as 2 theta by 2. But 2 theta is what? Angle CBD plus angle CDB is equal to 2 theta is nothing but that angle which we wanted, is it not? 2 theta is PAD, angle PAD by 2. And we have the proof. That's it. Okay, yeah, you can pause and have a look at the answer.